Welcome to Honors Geometry, Lesson 11.1, Areas of Triangles and Parallelograms. The area of a square postulate. The area of a square is the square of the side. And this is where the algebra and the geometry cross over. And that's why something to the second power is called squared, because it's representative of a square. This square has the length of one side is 4. So to find the area, square 4, the area is 16 square feet. Area congruence postulate. If two polygons congruent, then they have the same area. There's the same amount of area in both of these congruent rectangles. The area of a rectangle. The area of a rectangle is base times height. Okay? We know that the opposite sides of a rectangle are congruent. The base is 12, the height is 4. The area is 48 square meters. Area addition postulate. The area of a region is the sum of the areas of its non-overlapping parts. We don't have a formula for the area of sideways L. So what we need to do is either break it up that way or break it up this way, so we've got the area of two separate rectangles. Alright, so if we broke it up this way, we've got a rectangle over here. The base is 3 and the height is 6, so that would be 18 square inches. Okay, let's see here. What is the base of this? If this part is 3 and this whole thing is 10, this here must be 7 inches. If this part is 3 and this whole thing is 6, this must be 3 inches. So the area of this is 21 square inches. So the area of the whole composite figure is 39 square inches. Add the two together. Now if we would have chunked it up the other way, sorry, it didn't want to draw that line that I had there before when I backed that up. If we would have done it like this, then the area of this little square here is 9 square inches, 3 times 3, and the base of this is 10 and the height is 3 inches there. 10 by 3 is 30 inches squared. Hey, look at that. The area of the composite figure is 39 square inches. So it doesn't matter how you cut it up, as long as you cut it up into shapes that you can find the area of. Okay. The area of a parallelogram is base times height, just like a rectangle. And why is that? Because on every rectangle, on every parallelogram, you can take your magical scissors out, cut off an end, and bring it over here and make a rectangle out of it. That'll work for every parallelogram. So you've got a 7, a 17, and a 10. The perimeter, 10 plus 17 plus 10 plus 17. That would be different than the area. Bring this chunk over here. That 10 we will not even use for the area. That's kind of a distractor for the area. So the area would be 7 times 17. And I thought I had, there it is. The area is 17 times 7, 119 units squared. To find the area of that parallelogram. Alright, so there's And again, the area is 119 units squared. Alright, let's move along. The area of a triangle is 1/2 the base times the height. And that kind of looks like the formula for a rectangle or a parallelogram, and here's why. If you double that triangle and flip it over, you're either going to make a parallelogram or you're going to make a rectangle. And that's why the formula for the area of a triangle is half the area of a rectangle parallelogram. The height will always be perpendicular to the base. Sometimes with an obtuse triangle, one side must extend to find the height. Base is here, height right down the middle on this triangle. That's an acute triangle. On a right triangle, the base and the height are going to be sides, both. And then on an obtuse triangle, you'll have to extend the base out to get a height perpendicular. Alright. So, on this triangle, the area is, what is the base? 45 plus 21, 66. Height is 28. The area is 1/2 times 66 times 28. The area is 924 square units. This will conclude Honors Geometry 11.1 Area of Triangles and Parallelograms.